Right guys, it's finally here, the Z390 Dark. After a long waiting, the board is finally available on the retail market. I saw many of you guys posting some angry comments on my videos over the past few months that the board is not available, and I'm posting material about the board. But I want to tell you some little background story of the board. So the whole idea of the Z3 or the Dark concept on the mainstream socket is to produce a good, like flagship style overclocking board also on the mainstream socket after many years. If you have been following the PC scene for a long time, you probably know that EVGA hasn't been able to produce like really good and really wanted overclocking motherboards on the Intel socket since like the X58 and P55 days. Since last year, it all changed when we got the X299 Dark on the market. That changed everything in this regard. That board was really solid, and it was able to beat many of the flagship boards from other vendors. And now we have the Z390 Dark, which is a really good competitor to the other vendors also on the mainstream socket. So it's been like from 7 to 9 years since we had a board like this from EVGA on the mainstream socket. The last one was like the P55 classified or something like that. So, and that was in like 2010. So 8 to 9 years. So it's been a long time. So it's finally good. I mean, it's finally so good to see a board like this from EVGA, as competition can only do good to the consumer itself when it comes to being able to produce better products and push the competition even further. I have been really excited about this board, and I have been really grateful that Vince got me hooked up into this project. So today I will be taking you a quick look, like unboxing and overview of the board. Then we will go through the BIOS, go through all the options and what you should be using and all the tips, and then some quick overclocking test. Of course, you have already seen most of the stuff I've been posting like the last 2 or 2.5 months. We already know that the board has excellent like overclocking capabilities both on the CPU and on the memory. So the vcore requirements per given clock on this board, yeah, I mean, it's like within the top notch with the other flagship boards from other vendors, and the board is able to push the memory even past 5 GHz. We saw 4.9 GHz to 4.95 on the memory with 13 timing. So yeah, it's kind of already proven that the board is amazing for overclocking purposes, and it offers like really nice clean look even for daily system. So if you are not a fan of really like shiny bling RGB lighting, this board could be for you, as it doesn't have any. It's like really clean black overall look. So that is also an option to consider. The pricing is of course not the best when it comes to the overall motherboard market. At the time of making this video, the board came out only on the EVGA side at the moment for around $500 shipped, and that is around the same for the EU market, so around 500 euros shipped. Of course, you have the amazing warranty policies of EVGA, but yeah, the pricing isn't the best. I'm a bit sad for this. I was hoping for like 400 to 450 range. I knew it wasn't going to be out for under 400, as EVGA cannot produce motherboards same quantity levels as Asus or ASRock or Gigabyte. So I knew it wouldn't go out for like 350, but at the 400 mark it would have been excellent. So I was hoping for between 400 to 450, so 500 is a little bit much. I agree with this, but we will see if the price will come down once the overall situation settles and the board is fully available worldwide, not just at the EVGA websites but also in retail stores. So of course the EVGA warranty policies are excellent when they offer the consumer a direct warranty support and RMA returns. So that is also one thing you must always remember about EVGA products. So but without further ado, I think we should take a look at the board and go through all the details and features very accurately. So when taking a look at the box, we can see it's really like clean design. We can read Z390 Dark, designed for Intel chipset Z390, core 9th gen, and of course this board is designed especially for the 8-core 9900K and also the non-iGPU variant, but of course the 8-core anyways. So there's nothing else important on the back, just some advertisements for Elite software, which is their overclocking utility, EVGA warranty, as I already mentioned. So so what you get inside the box is you get your little USB with all the drivers. So they don't come with a driver's CD anymore. They only provide this little USB disc or stick. That might be a good or bad thing for you, as well, it's totally fine if you install Windows 8 or newer. I think most of you guys will be installing Windows 10 anyways. But if you are installing, let's say, Windows 7, many people still use Windows 7, trust me, even though it's kinda like unsupported for daily systems now. Windows 7 will not natively support USB with these new platforms straight away, so this will not work without the USB driver, either on the AS media port or on the Intel USB port. So you have to get the USB driver before you can install any more drivers from this. So that is the minus part. But of course many don't have optical drive anymore at the time of making this video anyway. So talking about the accessories, what you get is Bluetooth or Wi-Fi antenna, it seems. Some SATA cables. You get some screws for your motherboard. Not sure if these are for the M.2. You get little sticker. These are for the little test bench or the overall layout accessory, which it's just an accessory to show the layout of the board, but it works as a test bench as well. So these are the little standoffs for that little accessory. Some warranty information, guide. I don't think you need these anyways. This is the Pro-bit connector to measure all the voltages. This is really handy if you are using this. If you are using the board outside a case, you can measure the vcore accurately to test all the load line calibration levels. So keep this in hand, don't lose it. So just a normal SLI bridge. Then you get the IO shield. Some boards nowadays seem to have the IO shield already integrated into the motherboard, but this one comes with the this board comes with it separately in the box, but it's easy to use anyways. More SATA cables, thermal pads for your M.2. Then you have a secondary Pro-bit connector. So we can take the top part off, and there we can see the motherboard itself. Or first we can take a look at the accessory, which I already mentioned about. So this is the board layout accessory I mentioned about. So it shows you all the like the tracing on the board, all the connectors and all the connectors, etc. what are on the board. So you can see the location of the socket, the memory, how the VRMs are traced, and all the power connectors, ports, etc. And this also acts as a bottom for your test bench, so you can use the standoffs on the ADX locations where you can place the board itself, and you can use it outside a case. So it also shows what are the used power connectors, so we can see it uses intersil power stages, both for the vcore as well as for the memory. So smart power stage ISL 99227. Those components are really good. Of course, they are not cheap, but they have really amazing thermal capabilities compared to some other competitor options. But this is just something unique to EVGA. None of the other vendors have provided something like this with their motherboards, so it is something nice to see. So let's take the board out. So here is the Z390 Dark in all of its glory. So when I first time saw the motherboard in pictures in early October, it really reminded me of the old and legendary Asus Rampage Extreme motherboard from the Socket 775 days, thanks to the rotated socket. And I still consider that motherboard probably the best motherboard ever in the whole history of PCs. And the EVGA guys themselves said that they wanted the motherboard to resemble some of the old and legendary DFI motherboards of the same era, some of which had the memory slots located at the top part of the motherboard, like the Dark has. And also some of the cutouts for the power connectors make the Dark resemble some of the Asus Apex motherboards a little bit as well. But the first thing that really catches the eye with the Dark is definitely the rotated socket. The overall motherboard layout is very unique. It really stands out from the crowd. The overall motherboard design is very clean. It doesn't have any RGB lights on it, so it could be either a good thing or a bad thing for you. The Z390 Dark comes in E80X form factor, so you have to make sure that the case where you want to put this motherboard in can support that form factor well. The heatsink assembly is really massive. The VRM connected, the VRM part of the heatsink as well as the chipset part of the heatsink are connected together. The heatsink assembly has a lot of mass and a lot of cooling surface area, and we will be doing a burn-in test on the VRMs by running something like Prime 95 on the CPU and really see how high the VRM temperatures can go in the worst case scenario. So when the motherboard is in totally passive mode without any direct airflow towards the heat sinks. And I already did a temperature test with the ES model of the motherboard without any heat sinks on the VRM, and the results were already really amazing. So we can really expect that this motherboard has definitely one of the best VRM solutions on the market when it comes to Z390 motherboards. And talking about power delivery, the Z390 Dark has a 17-phase power delivery design. The vcore VRM is a doubled 6-phase, so 12 phases of 17 are for the vcore VRM, 2 phases are for the iGPU, and then there's 1 phase VRM design for the memory and for the VCC IO and the VCC SA. All of the power phases are made of Intersil components, which are very high quality but also quite expensive. The vcore phases are rated for 60 amps each, and the good thing about Intersil components is that they have direct metal contact on the top part of the MOSFETs, so they have very little thermal resistance. So Intersil definitely has one of the best, if not the best, thermal properties when it comes to power stage, MOSFET designs, and that really seems to show already when we did the temperature test with the naked VRM already. But when looking at the overall designs of the motherboard, there are 3 full-length PCIe slots. All of the full-length ones are wired directly to the CPU itself. The first one is wired maximum of X16, second one is X8, and the third one is X4. The black PCI Express X4 slot between the second and third full-length one, that is wired directly to the Z390 chipset. So the maximum multi-GPU configurations you can run with this motherboard are 2-way SLI or 3-way Crossfire X, although the importance of multi-GPU configurations has come down over the past few years, as they usually produce more problems than they resolve. So the maximum multi-GPU configuration NVIDIA officially supports now is only 2-way. You can still run 3-way and 4-way in some situations for benchmark purposes, but other than that, the 3-way or 4-way SLI isn't so common anymore, and it's a bit same for AMD as well. The audio part of the motherboard is separated from the rest of the PCB, which is quite common among high-end motherboards nowadays anyways. The motherboard has 2 full-length M.2 slots between the first and second PCIe slot. Also of note is that there's some exposed gold-plated copper on each of the M.2 slots. So what that does is the Z390 Dark has a 10-layer PCB, so it has 2 extra layers over the more common high-end design when it comes to mainstream motherboards. So you can use the included thermal pads between the actual M.2 devices and the exposed copper here, and then the whole motherboard PCB will act as a heatsink for those M.2 devices. So that is quite clever thinking from EVGA, I have to say. Then when looking at the right side part of the motherboard, we can see that the Dark has 8 SATA ports, 6 of which, so the bottom 6 ones here, they are wired directly to the Z390 chipset. The top 2 SATA ports, so the ones here, they are wired to a third-party AS-media controller in order to have better compatibility with some of the older operating systems, mainly Windows XP and its server equivalent, so the Server 2003. As some of the overclockers still use Windows XP very regularly, as some of the older tests have better performance in Windows XP, like SuperPi, PiFast, W-Prime, and even some older 3D benchmarks as well, like 3D Mark 2001, Aquamark, and even 3D Mark 03, 05, and 06 with some older graphics cards. There's the VROC connector, and since the whole CPU socket is rotated 90 degrees, all the power connectors are located at the right side part of the motherboard, so the 24-pin and both of the 8-pin CPU power connectors, and they are also rotated 90 degrees, So it's really easy to make the cable management look tidy on this motherboard, as you can hide most of the cables. I mean, for the most part, you can hide the cables underneath the motherboard. So only the connector part of the cables will come to the visible area. So that's something really nice. Same thing goes for the USB 3.0 and the USB 2.0 ports here. Also, the memory slots are located at the top part of the motherboard, and there are only 2 of them for a very good reason. So it's quite common now that the best overclocking motherboards have only 2 RAM slots or 1 slot per channel, and there's very real reason behind that. So the more common 4-slot design or 2 slots per channel design cannot reach as high memory speeds compared to the single slot per channel design. And that's one of the only things a motherboard manufacturer can do to really have an impact on the maximum performance and overclocking capabilities the motherboard can achieve, as it's quite common nowadays that you hear that it doesn't really matter which motherboard you choose, as the CPU or the memory will hit the same end result on any motherboard on the market. That's not true at all. And also the memory sticks, since they are located here, they will be very close to the cooling solution which you could have mounted on the top part of the case. So if you are running a, let's say, all-in-one water cooling solution and it's mounted at the roof of the case, and you might have fans on the bottom side of the radiator, the memory sticks will be very close to those fans. The motherboard has 8 fan connectors, so 2 of them are located near the 24 pin here, 2 near the center part of the PCB next to the heatsink, then 2 at the top, bottom right corner of the motherboard near the SATA ports. These, as well as the one here, they are rotated 90 degrees, and there's also one more between the first PCIe slot and the heatsink assembly here. The motherboard features 3 BIOS chips, 2 of which are soldered on the board, and there's a third one, socketed one here, which you could even remove and change altogether. So it's nearly impossible to fully brick this motherboard with failed BIOS flashes. So if one of the BIOS chips fails, you can just flip the switch to another position, enter the BIOS, flip the switch back to the failed BIOS one, then just flash the bricked BIOS chip with a working BIOS, and you can resolve it that way. And also you could have different BIOS versions on each of the BIOS switch positions. So you could have one that can do better memory overclocking, for example, in some situations for testing purposes, and then you could have the newest one in one location for daily use, and so on. And here are the dip switches for your PCI Express devices, so you can easily troubleshoot if you have any issues with the graphics cards. If you had, let's say, 2 cards configured with water cooling and one of them dies, you can really troubleshoot and see which of the cards is the faulty one without having to remove the cards from the system altogether. So that's really handy. Then here we have a slow mode switch. This thing does the same thing as CPU thermal throttling. So the slow mode switch will not work if you have a CPU thermal throttling disabled in the BIOS. When you flip the switch, it will drop the CPU multiplier from the max ratio to 1200 megahertz. So you can really keep the CPU cool and at low speed in between some of the tests, or if you are, let's say, trying to get the highest CPU-C core speed validation, you can quickly flip the switch from the slow mode state to the maximum speed, hit F7 on CPU-Z, and then quickly flip back to the slow mode state. So you can get some extra megahertz by using that function there. Then the power and reset buttons of the motherboard are located at the top right part of the motherboard. Next to them we have a red clear CMOS switch. Then we have an additional USB port here. That is for the BIOS flashback utility, so you can have the latest BIOS in a USB stick that is formatted into FAT32 format. You can just plug that in press and hold the reset button for a few seconds, and it will start the BIOS flashback procedure, which will show on the debug LEDs. So you can really you can even flash the BIOS of the motherboard without having even CPU or memory installed. You only need to connect the motherboard to the power supply. So if we get more CPUs in the future, you can just get the system working without using an older CPU first to get the newest BIOS in. Then next to the fan connectors we have a black safe boot button. So what that does is, if you do some changes in the BIOS, for example in the memory section, and those changes will make the whole system unbootable, what you can do is you can just press that button. It will load the previously worked settings without erasing the changes you made in the BIOS that caused you not to be able to post. So you can really fine-tune the settings step by step without having to clear the settings every time in between by doing a full CMOS clear. Then there are two debug LEDs. Those can do much more than just debug the postcodes, so you can even monitor CPU or memory voltage, CPU or PWM temperatures with that combination. So if you have the system set up in a case that has a window, you can even measure the real vcore value at the hardware level without even using a digital multimeter. So that's something really handy. And that's definitely the easiest way to measure the VRM temperatures as well, as not all the available software can measure the real VRM temperatures of each motherboard model that is out on the market. And yeah, there's also a little sound indicator for your post process, as well as a supplementary 6-pin PCI Express power connector for the PCI Express slots. It's not really needed, but you can still use it if you have, let's say, a two-way SLI system configured. Then when looking at the top part of the motherboard, we can see the two Pro-bit connectors. Here is a little printed guide on the motherboard PCB. It's not so easy to see on camera, but it will show what each of the pins will measure. So every second pin of the Pro-bit connectors is a ground pin. The labeling says that the first pin is called vcore, so that way we can know that the first pin will measure the actual vcore value. Then later on comes dim voltage, VCC, PLL, and so on. So that's also quite handy. Then when looking at the I/O part of the motherboard, we can see that the DAC has a PS2 combo port. So there is only a one port for PS2 devices. So if you want to use both PS2 mouse and keyboard, you must use a splitter Y cable. That will work just fine, as there is no separate PS2 connector for both mouse and keyboard. PS2 devices are still very popular among overclockers and handy in some situations. For example, if you are installing Windows 7 or older operating system, since Skylake's launch, so the original Z170, the USB ports haven't worked anymore natively when you are trying to install an operating system that is older than Windows 8. So you must either use PS2 emulation on the USB ports, or use actual PS2 mouse and keyboard to install Windows 7 or older operating system. And also PS2 has made a little comeback when it comes to the mechanical high-end gaming keyboards, as PS2 has lower latency and it's easier to support the N-key rollover through PS2 rather than through USB. Then next to that we can see the Wi-Fi antenna ports there. Another clear CMOS button at the back of the motherboard, dual LAN. Then we have 7 USB 3.1 like normal USB ports, USB 3.1 type C port, and a MIDI display port there. These USB ports here, so one normal USB 3.1 port and the C port, they are connected to a third party as media controller, and especially the top one, that is the only USB port that has functionality even in Windows XP. So that is still compatible with older USB 2 and USB 3 devices, and that is the port I use to take results out from the test operating system. For example, like test Windows XP for which I have used to run W Prime or SuperPi and things like that. And then lastly there's the HD audio. So here's the back side of the board. You can quickly see the cutouts for the power connectors, like the 24-pin and the two 8-pin CPU power connectors here, as well as the 6-pin supplementary PCI Express power connector for the PCI Express slots. Also, you probably can notice that there are no through-hole pins coming through the motherboard PCB at the memory slot area. EVGA has decided to use surface-mounted memory slots with this particular motherboard. I'm not fully sure how much that can improve the overall overclocking potential. Gigabyte used that option with some of their latest special overclocking boards, like the Z97 SoC LN2 board, the Z170 version, and so on. Also, if you look carefully, you can see that there's a small hole at the back side of the CPU socket. That is for placing a thermal probe underneath the CPU itself. So you could accurately measure the real CPU temperatures, but since the new Intel 9th generation CPUs are soldered, that is not so important anymore compared to the previous generation CPUs that had paste between the CPU die and the IHS. That way you could accurately measure the real CPU temperature and evaluate is the thermal paste contact between the CPU die and IHS still good. I personally never used it, as it is a bit risky, as placing the probe could short something, but the option was always there if you wanted to use it. So this is how the board looks like when it's mounted on the accessory board as a test bench. So the small screws that came with the package, they are just for this purpose. So the screws screw on from the other side of the accessory board to those standoffs. Then the board just sits on top of those standoffs. So this way you can pre-test all the components you purchase for your new system before you place them inside a case, so it's quite handy. And also you can use this for just benchmarking purposes overall, even on sub-zero cooling methods. Of course, the gap between the motherboard itself and the accessory board is quite high, so you have to make sure how you want to insulate it. But if you use the Kimping Cooling Inferno backplate again, it will be just fine, as the cold will not spread that much from the CPU socket area. So this is really something unique to EVGA. So that's pretty much it. The dock is very packed with features. There are many things to cover. So from here we can get on by mounting the motherboard in a test bench, go into the BIOS, go through all the settings and options that are in the BIOS, then do a little overclock test, and then do the VRM temperature test by running the CPU in Prime 95. So since we have everything set up, we can take a quick look of what we are running today. So the Z390 dock is mounted on a test bench. The CPU in the socket is a 9900K. This time only a simple engineering sample that is a bit above average in quality. And I'm not running the legendary 5.5 GHz water-cooled CPU this time. That did close to 7 GHz in Cinebench under LN2, as that CPU is no longer here. But this CPU will do just fine for this test scenario. The memory is the Kingston HyperX Predator 4133 CL19 dual channel Samsung B-die based memory kit. The power supply is the Seasonic Prime 1300 watts platinum, and as a VGA I'm using quite simple Galax GeForce 710 GT just to display the monitor signal. A simple 240 GB SSD plugged into one of the Intel based SATA ports, and then just a custom water cooling loop to cool the CPU. And for peripherals I'm using a PS2 splitter Y cable, so I can use both PS2 mouse and keyboard with this motherboard, as I mentioned earlier during this video. And on this motherboard I would always use both of the 8-pin connectors with the 8-core CPUs, as they can draw a lot of power when you start to overclock them. If you plan to do any overclocking with the 8-core CPUs, I would always use both of the 8-pin power cables. But here I will not be using either of the strong fans, so I can keep the motherboard area as passive as possible to really demonstrate the worst possible scenario when it comes to VRM temperatures. So from here we can just go into the BIOS, go through all the settings and do a simple like overclock profile and test, and then just test the VRM temperatures of the motherboard and then get onto a conclusion. So when you get into the BIOS for the first time, you will get some sort of welcome screen like this. What you want to do is just only use the advanced configuration, so the enter setup option. I've never used the gamer mode or the EVGA OC robot myself, so I can't really comment those. So I'm only using the retail BIOS, which comes with board at the moment. So what you get with the board is exactly the same as you see in this video. So in the first section of the board is the OC tab. So here are all the CPU overclocking options, like the clock settings, voltages, etc., as well as all the memory controller voltages and so on. So we can just go through the features first, then we can do a simple like overclocking tutorial test, how to go through all the settings. The second tab is memory. Nothing really special here. You can select either automatic, either of the two XMP profiles, or go through the settings manually yourself. The advanced holds all the feature options of the motherboard, like different devices which you can turn on or off, CPU features to turn any cores off, to turn any CPU features off, etc. So in the CPU section we could disable the speed step option or turbo mode, cease stage, hyperthreading, any of the settings, but you don't normally have to touch these, and so on. There's nothing really special here. In the onboard devices we can find LAN options, audio, as media, SATA port for the different SATA ports that also support the Windows XP, and the USB 3 ports like the 3.1A, which has compatibility even in Windows XP. SATA here you can choose between AHCI or RAID. In hardware monitor section we can choose if we want to monitor either the CPU temperature, PWM temperature, so the VRM temperature is this one, CPU vcore, or any of the other voltages and so on. So we will be using PWM temperature, as we want to measure the or as we want to monitor the VRM temperatures in our test. But yeah, nothing really important. I mean, important here. What you should be looking at when you are just building your daily rig. If you are doing any extreme overclocking type thing, then you want to disable most of the stuff that you don't need, like LAN or audio, etc. But yeah, in the boot section, you pretty much always have to change the boot mode from UEFI to legacy, especially if you want to install Windows 7 or older operating system. Windows 7 installation option gives you the PS2 emulation on the USB port, so you can use the keyboard to some degree when you want to install any older operating system than Windows 8. But this doesn't make your like USB sticks functional. This only gives the most basic level functionality to the USB devices, so you can at least choose the options when you are installing the operating system. And for example, you will see that the mouse will move very slowly, and this also has downsides. If you are using the emulation and you move the mouse during some 3D application like 3D Mark, for example, the score will go down a bit. So this will lower your overall performance when you use the PS2 emulation on the USB ports. That is also one of the reasons why many overclockers always use PS2 devices, as the compatibility is just so much better with the older connection type. But yeah, there's not really anything else that's important. Here in the last tab you can save your profiles, you can load and save profiles to a USB stick and so on. And yeah, in the extras you can find the stress test functionality that is included in the BIOS. I personally have never used this, so I can't really comment that much. There's also the OC robot, which goes hand in hand with the stress test, and there's also the BIOS update. So the BIOS update function is hidden in the extras section, and of course when you want to flash a new BIOS inside the BIOS, you must have the BIOS file in a USB stick that is that has been formatted into FAT32, and then you can just flash it via the BIOS update feature inside the BIOS. But yeah, so if you want to do like a simple overclock and a starting point, what you should be doing, so we go to the CPU multiply control, we select that to manual, then we can just put the if we want to do an all-core overclock, so that all the cores are running at the same speed in different applications. We can just do that for starters when you are just looking for stability and testing like your overclocks, etc. So I already know that my CPU will do 5.2 GHz in almost everything, but you should be starting at, let's say, 4.8 to 4.9, but most of the 9th gen CPUs will do at least 5 GHz, and the range is quite huge. There will be those bad CPUs that will only hit that 5 GHz mark, and then there will be those golden sample CPUs that will do 5.4 or even close to 5.5 daily, like the golden CPU you saw in my videos that did 5.5 GHz Cinebench on this exact motherboard at around 1.33 vcore, 1.34. But of course that's not daily stable, it's just Cinebench, but it's still quite good way to stress multi-core stability. Ring, aka the cache, it is not so important when it comes to performance compared to the actual core speed or the memory, but you should still be trying to max this out, and a good starting point value here is 4.5, and again the range is quite huge what you can achieve. So you can be looking from anywhere near like 4.8 or like core speed minus 500 megahertz to even 1-on-1 ratio with the core speed. You cannot run the cache higher than the core speed itself. So the maximum I could put here is 5.2. You cannot go higher on the cache than the actual core speed. But since the cache isn't so like it isn't so important when it comes to performance compared to the core, I just set something. So even when I'm on LN2, I never really try to max it out fully. I just try to get it to at some relatively good point, and then I just leave it there. So I would recommend you use a value of 45 as a starting point. AVX ratio offset. This is a handy value, so you can use this to determine a lower clock speed for any programs that can utilize the AVX. Those will make the CPU consume a lot more power, which will result in much higher temperatures and makes the CPU more unstable. So a good value here is anywhere from 1 to 3, or you could even run it at 0 if you only use a CPU overclock that has been tested for AVX stability. So you don't want a higher multiplier for non-AVX applications, and you just want to use one value for everything. Then you can use a value of 0 here and use the tested clock speed multiplier on the CPU straight away. VCLK, you can just always leave it at 100. There aren't that many reasons to really use it. Of course you could, but there's not really need, as we have a huge amount of memory multipliers now with this particular motherboard, so it's not needed compared to something like the ASRock C170M OC formula, which has a maximum memory multiplier of 4133. There you have to use the VCLK to get even higher memory frequencies. Extreme cooling mode and extreme voltage modes, these aren't really needed for daily testing. You have to turn the extreme voltage mode on if you are doing heavy memory testing, even on ambient cooling. So if you want to try to push memory voltage to, let's say, 1.9 to even over 2 volts, then you have to turn on the extreme voltage mode, as the highest memory voltage you can set with this disabled is 1.6 for the memory. vcore, I always use override first to test the stability fully, and then you can use the adaptive and find a good value that works, and it will go down when you are idle, but it will then use the desired value for multi-core situations to get to that stability. So even though when these CPUs are soldered, I would recommend you start with a vcore value of 1.2 and then work your way up from there. As even when they are soldered, they still run very hot, and it's really hard to keep these CPUs cool even with very strong water loop. But since I already know my CPU, I will be putting in 1.3 volts for the 5.2 GHz overclock. CPU vcore vdroop. It's not so easy to determine what is the best value. You have to test these values yourself with a multimeter against the set fixed vcore value to know what is the best low-line calibration option for you. But there's not really a difference between a motherboard samples, and I've already tested this. Minus 50% has been the best value in my testing. So with minus 50% load line calibration option, the vcore will be slightly over the set value under load. So that is exactly where you want it. So you want the voltage to be exactly at the set value or slightly above it. You don't want huge overshoot. So if I'm setting 1.3 volts, I don't want the vcore to be like 1.37 under load. I want it to be as close to the 1.3 voltage value as possible. vcore PWM frequency. This might affect your overall CPU stability a little bit, but the power stages themselves, they go from 300 to even 1 megahertz, so 1000 kilohertz. But we found that values over 800 caused a lot of issues actually, and the higher options will be removed in the next retail BIOS. So I would recommend you just use a value of 800 here. So as the motherboard already features a super strong VRM combined with excellent heatsink assembly, you should not ever get issues even with the 800 option, and this should be more stable than a value of 300 kilohertz, for example, but of course the difference will be very small. VCCSA and VCCIO, these only really affect memory overclocking, and you should be more than enough. I mean, you should only need a value of 1.15 on both of these, even with relatively high memory overclock for daily use. But you can use even a value of 1.25 on these, but I wouldn't go I wouldn't go higher than that for daily use. But of course it's impossible to say what will be dangerous over the long term. It could be safe to run even higher, but I think 1.15 is a really good value. Most of the other voltage options you find here are just for extreme overclocking. You cannot really benefit at all from the VCC PLL, PLL OC, or standby, or core ring PLL. These are just for LM2 overclocking to increase the range on how cold the CPU can go. So if everything is at auto, the CPU might lock when you hit minus 130 degrees on the CPU container, and when you get the right values dialed in, you can go to full pot, aka to minus 196. It's simple as that. And of course some of the values will affect the clock speeds you can achieve on LM2, like on the cache and just overall core frequency and memory. But for daily, you can set a locked value on the chipset, as on some boards, if the PCH was left at auto, it sometimes put a weird value on the chipset itself, so I often just dial in the stock value that it already reads in the BIOS on the initial post, like 1.06 here. So we can use around that for daily and all the testing. So that's pretty much it. It's very easy to dial in 5 GHz or above. It's most about vcore requirements of the CPU and about your cooling solution. So in the memory, if you just want to go it very simple, you can just load the XMP profile. XMP profile 1 will be the higher option, but since we already know what our memory will do, and you can watch the test video of this memory kit, which I did previously. So we will be using the 4300 MHz option again with 1.5 set DRAM voltage, 17, 18, 28, command rate 2 as the main timings, and I will just dial in some tidal values on the sub timings as well. The you can copy these values. These values will work. The sub timings will work with quite high variation of megahertz and main timing configurations. So 4 active window and cache write latency have very big impact on performance. 23 should work most of the time. It's quite good value in itself already. 16 would be the best value you can achieve. Lower might just give you more bugs than performance. Cache write latency, the lowest value you can ever run on this is 9. 14 is already a good value. So when you leave everything at auto, you often see a value of 18 on the cache write latency. So if you can go below 18, it's always a good thing. Write to read a command delay, a value from 10 to 14 is good here. TRFC, this is quite dependent on the voltage and the frequency range you want to run. Since we are running 4300 MHz, 360 should still be fully functional, and this is already quite tight for this frequency, and we will be running that. T-Refi, this is quite opposite to most of the other settings here. The higher the value, the better. So the best performing value you can put here is the maximum value, which is 65,000. But this might not be so easy to achieve most of the time, so you can leave this at auto first, then set the maximum value and see if it's still stable. The write to read command delay is tied to a few other timings in the BIOS section, so you can leave this at auto. The best values you can run here are 1 and 6. TCKA or TCKE, the best value you can run here is 4, and most of the time a value of 4 or 5 should work. Normally on auto it sets a value of 6 or 8, and we will be using a value of 4 here. When it comes to the third timings, the first 4 can actually most of the time be left at auto. They will be set quite well by the auto rules already, and actually same goes for the next 4 as well. The best value you can run in these 4 values, which you can see here are now 10, 10, 10, 11, is around 12, 12, 12 on each, and when left at auto it often sets the tightest value on these as well. These two are tied to the cache write latency, which you have set, and also to the write to read command delay. So if you have set 1 and 6 here, you can quite safely leave these at auto first. Then you can try to change them later. And the last part of the third timings I would set myself. So you can set 4, 4, 6 or 7 here. We can set 6, but you cannot run lower than 6 on the vcore-SG. So you should be running a value of 6 or 7 here. And then the last 3 are very important, especially the last 2. So VR, dash, DR and DD. These 2 must be set at a value of 4. If you set lower than 4, it might just actually lower your performance most of the time. So 4 is the best value you can run here, and you should be running that on both of these. The last part of the memory section isn't so important. You can just leave all of them at auto. RTL is mostly important when it comes to extreme overclocking. It's not so important when on air or water cooling. So at least for the most part, you can just leave them at auto. Sometimes they might bug. So if the correct values here were like 55 and 56, you sometimes might see that either of the memory sticks or channels will like bug, and you will get a weird value on either of the channels. So you could be getting like 63 here with very high I/O setting, when the correct value should be 55 and 5. So that is just an example, but for the most part you can leave these at auto. So now that we have set all the memory, some kits will gain from changing the DRAM VTT. So you might get a better result when you lower the VTT compared to the DRAM voltage, or even by going a little bit higher. So you can try plus or minus 50 here. So it's a good like baseline, but most of the kits will be happy with just the 0, so no difference in the VTT. In the advanced we can just set graphics to PCI Express, since we are using a graphics card, and we can even disable the internal graphics if we wanted to, like I just did here. We can see in the PCI Express section, we can see that we are using the last port, and it's running on X4 Gen 2. Nothing in the power section. We will not be disabling any of the onboard devices. Nothing in the USB. And yeah, you want to have the legacy USB support enabled as well if you are installing Windows 7 or older operating system, of course. SATA, we will not be running RAID, so we will just leave it at AHCI. And the hardware monitor, which we already visited earlier, so we will be monitoring the PWM temperature. And yeah, nothing else important really. The board is really solid, and it's really easy to overclock with this motherboard. The only really hard part comes when you have a CPU that doesn't want to go to full pot that easy on LN2. So in those quite rare extreme overclocking situations, the board isn't always that easy to work with, but it's still very good, and I have liked the board a lot. But so yeah, now that we have dialed in most of the settings, we can just save the profile to any of the profile options, but they will go from one to the last one. So if you just save the profile to the last one, it will go to the top. So but there's still many empty slots where you can save different profiles. So we can just do it 5.2 test as an example here. And now we can just double check everything that it went correctly, and then we can just go into the OS and just test the stability, and then we can test how the VRM performs and what will be the temperatures roughly. So now you can see that we made it into the OS. So most of you guys have already probably watched my earlier videos, so you probably know already how I test the stability of different overclocks, so both the CPU and memory. So if you want to make any changes into the settings in the OS, the best way is to use the EVGA's own Elite software, but of course you could use something like Intel's own XDU to do that. But Elite is definitely the best way to go with this motherboard. You can download the official retail version from the EVGA's website, but I can also provide the download link for this unofficial light version of the software. So the key advantage of this light version is that it has better compatibility with different operating systems, especially the old ones like Windows 7 or Windows XP. This one will work in any of the operating systems, as it doesn't require the Windows management instrumentation process running in the background in order to function. But this has like more limited options you can change in the OS. So of course you can do some basic monitoring with this one. In the overclocking section you can only change the BCLK, the CPU core multipliers, the cache multiplier, but in the voltages you can only change the CPU vcore, both in override and adaptive mode, and then the DRAM voltage. But this is actually totally fine. You can just use you can just set all the sub voltages manually in the BIOS if you are for LN2 use and so on. So you don't really have to change them in the OS actually. So of course the operating system settings options isn't so great compared to something like Asus or ASRock, but you can live with this, and this is actually totally fine. So we can try changing the so if we change the multiplier from 52 to 51, we can see the CPU clock speed drop to 5.1 gigahertz. It will be same in CPU Z as well, as we can see, and we can just use the Core 8 option to go back to 5.2 gigahertz on all cores. So that's pretty much it. So now we can do a quick Cinebench run. We can open Core Temp. Core Temp is definitely my favorite software when it comes to just pure CPU temperature monitoring, as it doesn't have anything extra unneeded things built in the software itself. Of course, both Hardware Monitor and Hardware Info are good applications, but they have so much or so many unnecessary things that you don't actually even really need. Of course, you cannot measure the VRM temperatures with Core Temp, but we will be doing that with the debug LED, so at the hardware level of the motherboard. So if we just start running Cinebench here, we can already see that the CPU temperatures immediately go to like mid 60s, so like from 61 to 68 or 69 degrees, and the CPU Z now reads a vcore of, it read a vcore value of around 1.32, so a slight like 5 millivolt overshoot under load versus what it was in idle. So that's exactly what I meant with the minus 50% load line calibration option. So that is definitely the best value you should use, as we don't want very high overshoot, and nor we want any actual V droop under load, so that we don't want that the vcore goes under the set value under load. That's what it is at idle. So that's pretty much it. There's nothing really. So now we could, if we could just test the overall stability of the overclock with, I mean, by just changing the settings in the OS. So now we could just test the maximum possible like cache ratio by just upping the cache multiplier from let's say 4.5 to 4.8 gigahertz. Just apply it, and then we can see in the CPU Z that it's at 4.8 gigahertz, and then we can just try it again, see if it still passes. Of course, Cinebench isn't enough to test the entire daily stability of the overclock. You have to use something like Pride 95. You can use either a non-AVX version or a version that uses AVX. That's all up to you. So with 4.5 cache we got a score of 2296, and by increasing the cache to 4.8, the score went up close to 30 points. So we can see that 4.8 was still fine. So now we can actually try 5 gigahertz, so increase the multiplier to 50 from 48 and just try it again. And now we can see that the system immediately hang. And normally with cache failure, how it differs from pure core speed failure is that if your core fails, you can normally reset just fine, but if you get like a cache failure, you might often see that the reset button doesn't work, and you have to do like a hard reset. So you have to power down and then restart the and it's exactly the same way now. So I just press reset and nothing happens. So now we know that the issue is in the cache, not in the core speed of the CPU. So we have to hold down the power button and then just restart the system, and then we can try again. Since 5 gigahertz crashed, we can try just running 4.9 instead of 5 GHz and see what's the score difference compared to 4.8. Of course, there's always quite a lot of variation when it comes to Cinebench scores. The score can vary really a lot, even with just, even with same CPU and memory settings. So the score is not really that constant. So here we can see that 4.9 is still running quite fine. So when you have the Elite software, it's really easy to like bin or like speed bin or speed test the CPUs just like that. But as you can see, we still got an error. So even 4.9 is quite on the edge. So 4.8 is very likely the maximum cache speed we can use with this voltage and cooling solution for daily use. So 4.9 might pass, like it will pass now, but it will very likely crash when we run something like Prime 95. And the score didn't really improve, it actually went down 4 points, but it might again be better now when we run it the second time, as the score variation is quite huge. Testing the memory is exactly the same as in my previous videos. So the best way is to test. So the best way to test memory is by running the HEI memtest software at full memory capacity that you have installed, and then just something like HyperPy 32M on all of the CPU cores and threads. So that's pretty much it. So from here we can just like test the daily capable CPU overclock in something like Prime 95, and then see what are the like the VRM temperatures after like a 30-minute burning test. So as you can see, the Prime 95 has been running for around 45 minutes now. The CPU is still at 5.2 GHz with 1.335 measured vcore by CPU Z. And when looking at core temp, we can see that the maximum core temperatures have ranged from 73 degrees to 81 degrees, and core temp is measuring 190 watts power consumption on the CPU itself. And I'm not fully sure how accurate that is, but those temperatures are already quite high for the 9900K. And when looking at the debug LED, we can see that it's measuring 66 degrees for the PWM of the motherboard. So that is a really amazing temperature result for the Z390 Dark. Considering that we don't have any airflow around the CPU socket, there's no direct airflow towards the heatsink assembly, so the board is in totally passive mode. So I'm trying to demo the worst possible scenario here. So when looking with infrared thermometer, it's measuring from 47 55, and chipset part of the heatsink assembly is around 45 as well. So those temperatures are really amazing, considering there's like no airflow on the motherboard. So it's both about the heatsink assembly as well as the components that are used on the motherboard. So the intersil MOSFETs are really amazing when it comes to their thermal properties, and the direct metal contact with the actual heatsink assembly. So that is really nice. You should not have any VRM temperature issues with this motherboard, and we are even running the Ryzen 800 kHz switching frequency on the VRM. Right then, on to the conclusion. Sadly, the video ended up being ridiculously long, but I really want to go through everything about the motherboard. go through all the features that it comes with, all the accessories that are included with the motherboard, go through all the settings in the BIOS, do a little overclock test for you so you can use the video as a guide for yourself, and then just talk about the motherboard overall. So the dark is definitely powerful. It really is something unique and different on the market. It really can push the memories high, as we have already seen 4.9 to 4.95 GHz stable with great timings like 14, 13, 13, and also 4200 MHz plus with 12, 11, 11 timings. The dark can handle both the older A1 and the newer A2 PCB designs, and also the vcore requirements per given clock are also excellent on this motherboard. So the dark is definitely there among the other flagship motherboards from other vendors, and it can really compete against them. And it's something really nice to see, as EVGA really hasn't had a great motherboard for overclocking since like the X58 and P55 days. I personally have not even considered EVGA motherboards as a viable option since those days until 2017, when the X299 Dark came out. I even called the X299 Dark the new revision of X58 Classified. And I have been really grateful that I have had the privilege of being part of this whole project. We got many things resolved during the last 3 months or so. One of the key issues was the common Samsung BDI slow post issue that was also present on this motherboard, and that issue is present on at least 95% of all mainstream motherboards out there on the market. It's really something annoying. It's more of a feature with Samsung BDI based memories, with when you are trying to push high memory frequency with 12, 11, 11 timings. And it really is something annoying when you are doing 3D benchmarking, for example, with multiple cards installed, and you have to wait a long time during the post process for the memory to train. So we got that resolved. So dark is there among the Maximus 11 Gene and Apex that don't have that issue, so that is really something unique. Then we also fixed some overall compatibility issues with Windows XP, the Elite software in Windows XP, and then just overall functions on the motherboard, and like things with the voltages when it comes to sub-zero overclocking. And I will be doing a Windows XP installation video later, so stay tuned for that. If you are more interested about the in-depth technical details of the motherboard, especially the VRM section, please go take a look at Buildzoid's overview of the motherboard and his VRM analysis of the Z390 Dark at the Gamers Nexus channel. That will be something interesting for you, as Buildzoid definitely knows more about VRM structures on motherboards and graphics cards than anyone else in the whole YouTube community. The only sad thing is obviously the price about the Z390 Dark. When I saw the 499 price, it got me a bit sad. I really was hoping for the Dark to come out for 400 to 450 euros. I already knew it in the start that the Dark will not come out for less than 350 euros, as the component choices are quite expensive already, and EVGA cannot produce motherboards in same quantity levels as Asus, Gigabyte or ASRock. And the overall motherboard pricing has come up over the past few years anyways, as CPUs now consume a lot more power in general. So the motherboards need to be better on average anyways. So like when the original Sandy Bridge and Ivy Bridge CPUs came out in 2011 and 2012, we could see mainstream motherboards, even with the Z chipset, to come out for as low as less than 100 euros. And now the overall start prices of motherboards is obviously much higher. But if you are already considering let's say Maximus 11 Gene, Apex, or the flagship options from Gigabyte or MSI, you really should consider the Dark as one alternative, as it is really something unique. It really is a capable motherboard. It is designed from the ground up for overclocking, so it is not your like a value gaming system motherboard or a workstation based motherboard, although you could build the either of the two based on this motherboard as well. It is all up to you. Of course, if you only have, let's say, 200 euros to spend on a motherboard, a max, then this motherboard is not for you, obviously. But if you are already considering one of the motherboards I mentioned, they are all in like the same price category anyways, and the dark really looks good in a case, as the black color scheme really fits many system builds. But yeah, if you like this video, even though it ended up being so long, please like and share the video so that other people can also find it, and subscribe to the channel, and thanks for watching, and see you next time.